Hello and welcome. Today we're going to continue the build-up of the Nemesis, focusing on the installation of the Transgo 2 and 3 reprogramming kit, as well as their 3/4 upshift valve that allows for wide open full throttle shifts from 3rd to 4th gear, along with some Sonics parts so that we can comprehensively address the hydraulics in this transmission and position it for success in a high horsepower, high RPM street strip type application. So I've not used this kit too often. I know it's a really good kit, and when you start adding up all the individual parts that Transgo makes available, you know, high rate return springs, the 700 SK Junior kit, which is what I typically use, along with a few other things that come with it, you know, you're pretty much at or even above the cost of the entire kit. So, you know, if you're going to do all that and you want to use kind of an out-of-the-box solution, this is a great kit to install. It allows for full manual control. You can convert your forward pattern automatic shift to full manual. We're not going to do that here. We're going to retain the automatic shift pattern, but you know, the kit does allow you to do that, you know, with some of the parts and procedures that it has you follow. All right, so just real quick, we're going to run through everything we need to do here. First and foremost, we got to get this valve body taken all apart. Then we got to drill a few holes based on what the kit provides for in your instructions. And then from there, we got to clean the valve body off. We'll position everything that needs to go back into it and reassemble it. Then we also need to put the high rate return springs into the forward coast clutch and 3/4 return spring assembly. That's to allow for centrifugal apply prevention, as well as cleaner 3/2 downshifts. I also have to get the forward drum over here because we have to R&R the bleeder ball capsule that comes in from the factory with Transgo's orifice that's a little bit more effective in bleeding off excess pressure, again, to further you know, mitigate the risk of centrifugal apply at high RPMs when driving through 3rd gear in 1st and 2nd. All right. We're also going to put together the Sonic Super Hold Servo assembly, install parts from the kit that go into the 2-3 accumulator area. That's basically the back of the 2nd gear servo. We need to drill the plate. There's a Transgo 700P spacer plate over there right in front of the pump. You see it there. You know, Sonic's instructions are kind of over top of it for now, but it's there. And then finally, we got to install what we need to install into the stator support for the pump. All right, we had to ream this thing to facilitate installation of the Sonic's oversized pressure regulator valve. I have a complete video that shows that process from start to finish. Check it out, and that's on this exact same transmission on that exact same pump. And so we're going to do that. Install the Sonic's TCC apply valve with the scarf cut sealing ring, as well as the 1/2-inch boost valve from Sonic's that has O-rings. So so basically, and then the 1-2 accumulator has its own set of springs as well. The 3/4 accumulator will not be used at all, where, you know, that's been blocked off. That's like one of the few things that company that originally built this transmission did correctly. They did block the 3/4 accumulator, but you know, everything else was done pretty much half-assed or not at all. Anyway, as you can see, we have a converter there on the bench. That's for this transmission. It's 2500 stall. So we're going to set up our shift calibration to align with that stall speed, vehicle weight, usage pattern, and all that. So we'll walk through that whole process and what you should be considering. All right, it's raining out, windy, so I apologize if there's background noise. The shop door is closed, so you know, try to reduce the you know, the distracting noises in the background. But you know, if you're having trouble hearing me, again, I apologize in advance. But I can't delay the build just because of, you know, inclement weather. So, all right, let me get all this stuff pushed to the left of the bench, get the valve body front and center, and we'll go ahead and take that apart. So let me cover a couple of things real quick before we start tearing into this thing. You need to know that there were 4 distinct designs of valve body for the 704 over its production life cycle from 1982 to 1993. There was a first design, which is in production from 82 to 86, a second design, which is 1987, 1 year only, a third design, which is what we're working on, and it was in production from 1988 to 1992, and then a fourth design that was in production in 1993 for passenger car applications only. So the primary differences between the first generation, and when I say first generation here, I'm talking about the first design valve body, second design valve body, I bucket them into one generation, is the presence of a torque converter clutch control valve train. So if you come over here on this side of the valve body, you'll notice that this board here is completely blank. In other words, there's nothing here. In first design valve bodies, from 82 to 87, your first generation I should say, the first design and second design valve bodies have a bore here. And in that bore you can install a torque converter clutch lock-up valve train that will allow you to 100% control the torque converter mechanically through the valve body. Okay, you do not need any sort of electro or electronic input to manage converter lockup. In other words, your foot, okay, your right foot will control when that converter locks up. And so Transgo, Superior Tech, and I think Transtar have come out with different kits that you can install in here that have different springs, and you install whatever spring you want based on when you want the torque converter to lock in fourth gear. Okay, that's for first and second design valve bodies only, 1982 to 1987. 88 and up, they got rid of that, and it's all electromechanical. So if you're retro modding like a 700R from 87 on up that does not have this, because some of these valve bodies, you know, they started installing into late 1987 production year units, then you'll have to install what's called an internal and external lockup kit. All right, the other major difference between the 82 and 86 valve bodies and everything that came afterward is the design of this valve train right here. This is going to be your 1-2 shift valve and throttle valve. Okay, 82 to 86 had a valve train right around in here known as the 1-2 low range upshift and downshift valves. They do not exist in these later valve bodies. So this is important because depending on whatever kit you're using, and this is especially true of Transgo stuff, they will have you do different things in different locations based on the design of the valve body you're working on. Now they kind of divide all of these four different designs into two groups, first type and second type. So you have to read their instructions, and when we get into that kit we'll point them out to you. You'll have to read them carefully if you're working on these you know, transmissions for the first time, or you're using these kits for the first time, to know what valve body you have and what set of instructions to follow in the areas of the instructions where the you know, the direction they're giving you, the procedures they're telling you to do, are based on the design or type of valve body that you have. All right, so anyway, disassemble valve bodies, you just need some basic tools. For 704s, you want like either a sensor socket or I think a 1-inch socket, you know, 6-point will also work. Now take off the little pressure switch for the fourth clutch, and then, you know, pliers, a few different picks and scribes, a small roll pin punch for dealing with roll pins, a hammer, and then a couple of screwdrivers, small and medium. There may be some other tools that you'll find as we go through it. If I run into problems, I'll have to start pulling some different things out to, you know, get things out of the way, but that's the basics that you'll want to have. All right, so let's go ahead and start. So I already have the TV valve out. I took these out during the teardown of this thing because I wanted to see if they did anything at all for the main throttle valve lineup. They should have installed a Sonex, a Transgo no-stick TV valve and a Sonex TV sleeve and plunger kit for anything, you know, performance oriented, and that's the assumption that we need to make based on the way this company advertised this transmission. You know, they advertised it to handle 500 horsepower, and so, you know, you'd think these modifications and these parts would have been installed, but nope. All right, I'll flash a diagram on the screen. It'll give you all the different, you know, valves, their designation, location, all that stuff, so that you have that handy. And then there's other things you can do yourself with these valve bodies to modify them for performance use. I'm not going to get too much into detail about that here. I do have a separate video that walks you through all the different tips and tricks that you can do, or at least most of them, with these valve bodies, so that you know, you don't have to spend money on shift kits if you don't want to. But suffice to say, what we're doing here is a little bit different in the sense we're going to basically roll with an out-of-the-box solution. Alright, so this is going to be your 3-4 relay valve and 4-3 sequencing valve and spring. They're identical in terms of their design and function to 4L60E valve bodies. If this valve here is installed like this, you will not have any 3-4 upshift no matter what what else you do. So make sure that the end with the 2 large spools goes inboard when you put it back. Alright, I already preliminarily cleaned this thing. What I've been doing lately is actually taking the entire assembled casting, doesn't matter what valve body it is, whether it's cast iron, aluminum, early model, late model. I've been taking it and washing it in the parts washer before I do anything else with it. It's a lot easier to work on a valve body that is not absolutely disgusting, and you don't have to worry about hurting things like solenoids because you're not going to reuse solenoids anyway. Alright, you would never do that. Now, if you do plan on reusing the solenoids because of budgetary considerations, then you'll want to take those solenoids out and maybe put known bad solenoids in their place so the valves don't pop out. Alright, so, oops. So anyway, that's kind of a practice I've been engaged in as of late, and there's been like 0 consequences, 0 adverse impacts to anything as a result of me doing that. Alright, one other thing you may want to have on the bench too is a pencil magnet. So if valves want to get uncooperative on you, pencil magnet helps. And speaking of this, cleaning the valve body also removes all the nasty fluid, and at the same time removes that suction effect that can otherwise, make valves be stubborn and want to stay in the bores, despite your attempts to remove them. So, alright. This is the accumulator valve and sleeve. So you just kind of wedge on it, pry on it a little bit. From the rear here, you should have access in behind the valve and in behind the sleeve. And sometimes this plug will come out for you, sometimes it won't. If you're filming a video like I am, it absolutely will not cooperate. But once you get it started, there's a rectangular cutout here. I'm just checking the camera, make sure you can see. Alright, you can pull on that, or pry up on it rather. I don't want to break that screwdriver, so I need to pull another one out. One that's a little bit thicker, but could still get in there. Into that little cutout. Alright. In real extreme cases, you may actually need to use a slide hammer here. So here and on the 4L60Es, the accumulator valves, the sleeves will sometimes be stuck. I mean, it happens from time to time. Alright, I wanted to get this back side here exposed. There's a slot that you can then use to pry or engage, with a hammer. And get the valve and sleeve out of there. So there's a spring inside that Shift Kit will have a different spring that it will have you use. But it's a lot easier to clean off all the valves when they're not absolutely filthy dirty. Okay, the spring literally doesn't want to come out. There it goes. So this spring basically functions as an accumulator regulator, and essentially the valve's job is to allow a percentage of apply fluid to flow to the accumulator, so the 1-2 accumulator in this case. And so depending on what kind of spring you put in here, that will change the amount of fluid going to that accumulator, percentage of fluid going to that accumulator. So by extension, or I should say by consequence, that will change the speed in which the 1-2 shift occurs. So, you know, you can manipulate this however you want. To keep it simple, I would just, you know, especially if you're relatively new, I would just follow the shift kit's instructions and then tune the shift based on the feed holes in the separator plate. Let's see if I can get in there. Alright, so we're going to reach for another tool. Just simply a different pair of pliers. Alright, so this is going to be your line bias valve, and for full race or serious street strip applications and very high stall converters, I generally will just simply block this off with like a rod or something. The old school B&M shift kits will have you do that, and they give you like a little rod, and that will basically hold the line bias valve frozen in place. But for street driven vehicles, I generally don't do it. I mean, there's some springs in whatever shift kit that you use or you buy that you're not going to use in the accumulator position that you can use in the line bias position to kind of limit the line bias function upwards of maybe 70 to 80%. Again, my 700R4 performance tips and tricks part 1 valve body video covers all that. So when you're done watching this, if you want to learn more, feel free to check that out. All right. Let's get this roll pin out of the way. Of course, that don't fit. Alright, this is going to be your 3-2 downshift valve. It's very common to just block this valve inboard. In the kit, this kit, Transgo gives you a different valve to install in this position. So we're going to install that valve. Alright, so this side of the valve body is empty. Let's flip it over to the other side. First, let's get the manual valve out. You want to inspect the manual valve, especially around here. I've seen a few 700R4s come in relatively recently, like, you know, meaning over the last few years or so, where this valve is actually cracked here. And what will happen is it will become disengaged from the little linkage arm that basically connects the manual valve to the booster cone. And so, you know, when you get into the vehicle, start it up and throw the thing into reverse or drive, if this is broken, you won't have any movement. It'll just sit there, and you may be tempted to think the pump failed or something, but it's that valve, it cracked, and the linkage arm is just kind of dangling, if you will, or maybe it's at the bottom of the pan. So just FYI. Alright, now we're going to go and deal with the shift valve side. This is the TV side of the valve body, and this is the shift valve side. And that's my terminology. I don't know if you'll see that, you know, being used in manuals or by any other builders or whatever. All right. 1-2 throttle valve sleeve usually isn't fussy about coming out. It'll usually cooperate, and you can use small needle nose pliers and wiggle it free. But you know, sometimes you're gonna have to use bigger pliers. I mean, whatever valve body you're working on. And it would help if I pried against the correct valve. This is the 1-2 shift valve. Here's the 1-2 throttle valve and sleeve. As I was mentioning earlier, this entire valve train was redesigned starting with the second type valve body. The second type valve body, 1987, will have a valve train that looks just like this with this giant sleeve. So there's a sleeve, and then the rest of this stuff will follow it. Alright, that's your 1-2 shift valve. Next is going to be the 2-3 shift valve. And this kit comes with a different 2-3 shift valve, I believe, for type 1 valve bodies. So that's going to be your first generation with the torque converter clutch, you know, control valves and all that stuff in there. Alright, so this valve, you got to get in behind it, and it can be a little tricky because it's not that big. Once you do, you'll easily be able to get the throttle valve sleeve and valve out of the bore. Okay, so far so good with this valve body. I mean, it's cooperating with us. It's not giving us any grief. You know, valves are not being stubborn. But, you know, as soon as I say that, of course, you know, maybe this valve will turn into a nightmare. Hopefully not. This transmission had a you know, significant catastrophic hard part failure. You'll have pieces of metal all up in the valve body, and that will also frustrate your attempts at getting everything out. So it's another reason why I like to clean them before I pull all the valves out, or I try to disassemble it, because a lot of times cleaning will wash all that stuff out as well, and it makes extraction a lot easier. So like I said, you're not going to hurt anything by throwing this thing in the parts washer or hot tank, or even power washing it with like a, you know, a pressure washer. You know, I use both in my cleaning cycle, and you know, it's a potent 1-2 punch when it comes to cleaning parts off. Alright, now we have our MTV upshift and downshift valve. MTV is a, you know, modulated throttle. So it's common practice to leave the MTV upshift valve spring out and just, you know, put the valve in there. And that's this valve that I'm taking out now, right here in this position. And I'm trying to take this valve out with the freaking roll pin still in there. So this little land right here, right there, is where you want to stick your screwdriver if this doesn't come out willingly otherwise. You know, pry against that land and it'll pop it right out, as you see, or saw rather, but you may want to keep a finger there because that spring can fling the little plug across the way. fall out. And we have our spring behind it. All right, 1700R4 valve body, all disassembled. So minimal cleaning to do. We're just gonna kind of go over with brake cleaner, wipe it down, spritz it. This one I might stick in the washer along with that after we drill the holes, and then we'll proceed with the installation of shift kit and get the valve body all done. All right, let's start going through the kit. Drag it over here. Let's see what we got. All right, Transgo reprogramming kit. All right, so they do give you a set of gaskets. And as far as I know, these gaskets are not unique in any way. They are the same gaskets that you would receive in any 700R4 packaging. And it looks like they are set up for auxiliary valve body and non-auxiliary valve body. It really doesn't matter if you have a non-auxiliary valve body unit, whether there's holes here or not, because the reverse hold down plate will cover them all. All right. So here is your high ray return springs. All right, these are going to go into the return spring assemblies. This is going to be your no stick throttle boost valve, the 2 springs, a couple shims, a little spacer, and then the main TV boost spring here. All right. Assorted springs for various other locations. This is going to be your pressure regulator valve spring for the pump, accumulator and line bias valve springs, some plugs for the case, a large check ball, and springs for your accumulator and line bias valve. All right, so this is going to be your 3-2 control valve lineup. So you have your valve, your plug, and your spring. There are 2 different sets of 3-2 control valve plugs and springs in here. And when you use is going to just be based on largely the diameter and the valve body that you have in terms of the bore. So if you're going to be using the large diameter valve, you're going to use the white spring. Small diameter valve is going to be the yellow spring, and then you install the appropriate bore plug, and that's basically it. And then here you have more plugs. These plugs here for the spacer plate. This thing here, this kind of spring wire-like thing, that's for your governor to hold the primary and secondary weights wide open for full manual control. And then it has shims for your servo so that you can bring the entire servo assembly, including the apply pin, closer to the band to tighten up your band clearance. And I noticed they don't have a golden washer in here, so this kit anyway is using those smaller washers. The golden washer is a big washer that would go right in front of the servo cover, and that would accomplish the same thing. And then you have your box with, the little sticker in there. All right, I'll put this on the other bench. All right, going to change the position of the camera so that we can focus on the hole drilling, because we need to mark the locations where we need to drill, and then we'll go ahead and drill those holes, and then from there get this casting cleaned back up and install all the parts that go into the valve body from the shift kit that we're going to be using, and then reassemble the valve body with those parts. All right, we'll bring the valve body back over so we can talk through the holes that we need to drill in this thing. So let's grab the instructions, and I'm going to turn to page 3, and that's where they give you everything you need to know. Now again, we're only going to set this up for a forward automatic shift pattern. We're not doing full manual control. If you were, you would follow these instructions here, and anywhere it denotes stick only. So we got to drill 3 holes in the valve body. First hole is going to be here at the bathtub, 110 thou pilot hole, and then 157 thousandths finish hole, and it's going to go perpendicular to the bathtub. Then, to facilitate the installation of their 3-2 downshift valve, we need to drill 110 thou hole here for venting, and then they have you drill another hole at this location only through the bottom of the casting, not the whole thing. So in other words, don't drill through the top of the bore, top of the valve body. So they're saying the bottom, but you know, we're looking at it upside down, so you know, just to clarify. All right, so let's mark the locations where we want to drill. So first hole is going to be here. Second hole is going to be down there. And the third hole is going to be at this location here. So you'll want a center punch and then obviously a drill. And then let's take a look and see what bits they have provided. So here are the bits. Our 157, and here's our 110. All right, let me go grab my center punch and then we'll resume. So try to get as close to the center as you possibly can. And then start your center punch. Now you want to make sure that you get enough of a divot started so that the bit doesn't want to walk around on you. Alright, and then same for here. This is only 110 thousandths. And they do not want you drilling, you know, through to the other side of the casting. All right, we're going to start with our 110 thou bit. And then I'm going to start with, actually I'm going to start with this hole, then we'll do this hole, and then I'll do this hole. Because I don't have a center punch, at least not in this area, that will allow me to get all the way down there. This one, unfortunately, doesn't fit. All right, one down, two to go. What I'm doing is I'm going to eyeball the casting. I want to make sure I didn't punch through it. No, should be good. This one's going to be the trickiest because we have to drill at an angle. So that's our 1/10 thou. Now we're going to wallow it to the 157 per the instructions. Okay, I was not happy with the way that, you know, where I was entering on this side. I felt it was too deep, and I was actually going to bypass the bathtub and end up drilling through you know, this part of the casting if I had kept going. No harm was done to the valve body. I mean, like I said, it's not going to hurt anything. So if you have that issue, just stop and course correct as you need to. All right, this has to go in the tank, and then once it's all cleaned up, we'll go ahead and reassemble everything and be done with the valve body. All right, now we're ready to go ahead and put the valve body back together. It's all cleaned up, so I'm gonna lay out all the parts from the shift kit as well as that 3/4 upshift valve in their relative positions so that we can begin the assembly of this thing and get that done. So we'll pull the 3/4 shift valve out and take a look at it. So this is the kit. It's really not a shift valve, it's really a throttle valve. Alright, so here are the instructions, and to be clear, I'll put all of the instructions in the description, your links thereof, so that you can quickly navigate the Transgo's page. But basically, the whole gist here, and the whole reason you'd want to do this, add this valve into your valve body, is that it allows for wide open 3/4 upshifts. Now, notice here they do mention that you need 175 or higher working pressure to achieve the effect that this valve is designed to achieve. So you want to pair this valve with the installation of at minimum a 471 boost valve to get you what you need, preferably a 1/2 inch boost valve, or 472 rather. So it basically installs just like the factory one, no different, and all you're going to do is determine which spring you want to use based on how late you want this wide open shift to occur. So you got three options: yellow, blue, and beige. Based on the way this customer has set up his governor, I think I'm just going to go right in the middle with the blue spring. He is running a tighter stall. His cam, it's not like a ridiculously big super race oriented cam. It's really like a nice upgrade over a stock cam, but I don't know that it would be ideal to install the spring that corresponds to the latest possible shift, which would be the beige spring. So this is the blue spring. It's going to go just like this, and then we install this in the sleeve. So I'll put some WD in here. And just test fit it, make sure it's okay. And it's going to go in this position here. So we're going to delete this. I'm sorry, it's going to go in this position here. My apologies. We're going to delete this and this. And we're going to be left with this, with this. So it's all set to install it in the 2-3 position. All right. So what I'm going to do is I'm going to have these springs in this little package here, and it's going to be part of a small cadre of parts that I'm going to hand back to the customer with some instructions on exactly what to do, so that he can kind of fine-tune this thing once he's has it back in installed and has taken a test drive. Because I want him to be able to kind of self-serve to some extent, and have the ability to swap parts out if he needs to. All right, now we're gonna go ahead and install, or not install, but just lay out. I'm all over the place. Lay out our 2-3 or 3-2 control valve. So 3-2 control valve. It's gonna go right here. Okay, we're gonna delete the factory valve and spring. And we're going to install the smaller diameter valve because that's what corresponds to our bore. So we'll go ahead and turn the valve body around. So you see our exhaust hole. So what Transgo has you do is match to the diameter of the bore. Actually, maybe it's the big one. Hang on. Nope, it is the small one. So whichever one fits in there, that's what you have to install, you know. So valve, bore, and yellow spring. The big valve is associated with the white spring and the larger diameter bore plug. All right, so that's what we want to go by. All right, now we'll go ahead and lay out the rest of our parts. So springs for the accumulator and line bias, and then the main TV board components. So you have your no-stick TV valve, its associated springs, you have your main TV spring, and then we are going to install this sleeve and plunger kit from Sonics to kind of checkmate or head off any possible line rise issues associated with this thing here being worn out. So common problem with 700 R4s as they're getting up there in age is, you know, when you go in, stab it, fill it with fluid, do your pressure test, got your TV cable set up and optimized, your line pressures at minimum TV at idle are going to look perfect across the board, but as soon as you go full TV, your line rise is anemic. In other words, instead of getting maybe double or even triple the pressure that you would have at minimum TV, at full TV, you only have maybe a 10 to 20 or at most 30% increase. And that's a relatively common issue with these transmissions. So I always recommend, and I've been doing it as of, you know, last few years or so, I always recommend you install at least one of these two kits. This one is for basically factory controlled 3/4 upshifts and 4/3 downshifts. Factory controlled meaning it is going to shift before you hit wide open throttle when you're in third gear. It's going to shift the fourth gear. Now, if we weren't installing that other valve over there, then, and we still wanted to achieve that wide open throttle 3/4 upshift, your options at that point are twofold. You can either install the other version of this kit, which is 77966-94MK. That's going to be your you know, wide open 3/4 throttle upshift plunger and sleeve capable, you know, component. If you don't want to do that, basically you modify the factory sleeve to do it. All right. So what Transgo has you do is compare your main TV boost spring, your throttle valve boost spring, to the spring that already came in there. And if the original spring is longer than this spring, you install the original spring, not the Transgo spring. So the spring that came in this transmission is either identical in length or ever so slightly longer. So I'm actually going to install the original factory spring first, or, you know, initially. That's what I'm going to go back with. And again, we're going to add this spring to our you know, small bag of parts that we're going to give to the customer. So if he needs to do some tuning with the TV spring, he can do that. Alright, now we have our valve. Okay, no stick TV valve. This is what you want to run. So install this spring here, just like this, with the wide end facing inboard, and install the little spring here in the snout. Alright, now we'll go ahead and put a washer and the spacer. And then we'll open up the plunger and sleeve kit, which also comes with a spring. So we'll compare the length. This one's even longer. So we'll add it to our bag of parts. And then let's pull out the plunger and sleeve kit. All right, that's what it looks like. As you can see, it is very finely machined, so it's a good idea to put some WD-40 and get the inside of that sleeve lubricated to receive the plunger. And it should be good to go. This can's pretty much done. Alright, last bag we're going to open up is going to be for our springs associated with the accumulator and line bias valves, and we also have a few other things in here, including the pump pressure regulator spring, as well as a new snap ring for that location, so we'll put that over there. And then we have an assortment of other springs that we need to install. So we're not going to install all these, obviously. Your accumulator and your line bias valve springs are going to be, let's see, I think we have this white spring that's going to be accumulator. I believe this is also accumulator. And then line bias springs, or I think this is the line bias valve spring. And I say I think because these springs, I believe, are different colors than the SK700 Junior. So line bias is actually red and blue, so again, I was mistaken. So here are your two options for your line bias spring. And how you want to determine which spring you need to use is based on the size of the boost valve. So we're going to install the blue spring because that is what is called for anything 471 thousandths of an inch or greater. Alright, so we'll keep this one aside for the customer in case for whatever reason he wants to put it back in. You know, all out race, you just block that off. And then for accumulator valve, it's going to be either the white spring or the brown spring. So the white spring is what you want to use if you want a little bit firmer shift. That's going to further limit accumulation in the 1-2 circuit. If you want to install the brown spring, that'll provide for a little bit more accumulation and a slightly softer shift. So because we are using a large ratio servo, much larger than the Corvette servo, I'm actually going to install the brown spring. Okay, And then we're going to give the customer the white spring and the factory spring so that, again, he can do fine tuning. All right, and same with the line bias valve. We'll give him back the red spring so that he can do he can do fine tuning. Excuse me. All right, the last spring in here is actually for the 2-3 shift valve, and so if we look at the instructions, we see that Transgo has you use this spring only if you're doing full manual. And that's this black spring right here. So we're not going to do that. So just put that aside. We got a large check ball. And then we have a couple of plugs that would be installed into the valve body. These are non-orificed plugs. They're solid through and through. They would go into the valve body at these locations right here if we were doing full manual conversion, but we're not. So we'll put them aside. All right, so I think we have everything that we need on the bench to go ahead and assemble the valve body. I'm actually going to assemble the shift valve side first, and then we'll finish up with the throttle valve side. And I still have to pull another roll pin for the inboard position on the TV valve. The one that's on the bench here is chewed up to high heaven. All right, lubricate your bores. You can assemble the valve body with transmission fluid. You know, Dex Merc is fine. If you want to use Dex 6, if you're going to run Dex 6 in the transmission, you can. I've had a couple customers tell me that Dex 6 gave them kind of weird issues. You know, it would slightly flare shift, or you know, the shift timing wasn't quite consistent. And one customer told me that once he flushed his system out and put Dex 3 in it, you know, all the problems went away. So, you know, I guess take that for what you will, but I get a lot of questions about, you know, hey, is Dex 6 good to run in 700s, 204Rs, you know, the older transmissions, and, you know, that's generally how I respond. All right, let me show you the holes that we drilled, in case, because I know there was, you know, a lot of shavings and whatnot, but here is your 2 holes for your 2-3. This is the hole that they had you drill in this location here. All right, then you have the hole 157 thousandths that they had you drill through the bathtub, and you can see on this side where I kind of went in just a little bit too steep of an angle, so I stopped and I approached it from this side. And, you know, going forward, this is how I'm going to drill it. I'm not going to drill it from this side, I'm going to drill it from this side, and that'll basically guarantee that I place the hole right where I want it through the bathtub. Because here, I went in a little bit too steep, and I was actually drilling, like, you know, deep in through this part of the casting, where if I had kept going, I would have ended up here, and I would have had to weld repair that. And then the last hole is right here. So, not a perfect exhibition of hole drilling, but I believe it's good to go. I mean, no reason to believe it's not. So this is going to be your 1-2, your 2-3, and your 3-4, and then if you had first design valve body 82 through 87, you would have had your converter clutch valves in there. So just like this, the shift valve. And you want that to drop in under its own weight. All steel valves should drop in under their own weight. If they don't, if they're getting hung up, just polish the bore with bench buddies. Alright, so we're going to lay the valve body back down to put the throttle valve in. This is going to be your 1-2 throttle valve and sleeve. Roll pin goes there. You don't want to force anything. if it's not going to go in kind of on its own, so to speak, you just take it back out. And then you can also do this. Just kind of hold it up inverted. And I still don't want to go in. And that's because the one shift valve is hanging up. All of a sudden, this valve body doesn't cooperate. Alright, that's in. The main thing I'm trying to avoid is having the sleeve damaged by this valve, because I want to force it in because I get impatient. And that's like the worst thing you can do, as a transmission builder, or really anything that involves a lot of very kind of tedious and ponderous type, work, is to get impatient. And I'm a naturally impatient person. Like I want stuff done yesterday. There we go. Alright, that took way too long. Normally they don't take anywhere near that long to go in, especially this valve, this valve train, and it's usually pretty easy going. It's not going to give you too much grief, but I don't know, this one is just a pain. It was a pain. Alright. 2-3 shift valve. And then our 2-3 throttle valve. And to see where you're at with respect to the roll pin and the little groove, you could just hang the valve body over the bench like this. And then you can kind of look through and see where the groove is. So right now everything's lined up. The roll pin started. All right. Very tedious, and not only that, very sloppy. It's like every time I go to film something, I could do this with my eyes closed unless I'm filming. And it's only when I'm filming do I have these problems. I mean, yeah, it sounds like I'm making excuses, but I'll be honest with you. It happens far too often for it to be just coincidence. These things don't want to cooperate. They're getting hung up. It can be very frustrating when you're trying to look like you know what the hell you're doing. Instead, you end up looking like a fool. All right, so this valve is going to go in with the roll pin facing left. All right, the kit does not have you leave out the MTV upshift valve, so I'm gonna actually put it back in. A lot of kits do, but some simply don't. This one doesn't. And we'll see kind of how how the test drive goes. I mean, it was in initially, and when the transmission was in fact working, the customer seemed like seemed like he was okay with it. But like I said, we can always make adjustments. I mean, if worst case scenario, something's up and he's not comfortable doing a whole lot of reconfiguring, I can always shoot down there and help him out. Just spend a day with him to get it all dialed in. We'll see. We'll see how it goes. All right, so the shift valve side is done. So now we'll move to the throttle valve side. So I can eke out the last bit of WD-40 I have in this can. Alright, so this is going to be the 2-3 shift valve. Do that first. And let me double check. I'm almost positive that the threaded side would face out. The assumption there is that you're using like a bolt with a slide hammer to pull that thing out if you needed to. So if you look carefully, it appears that the side that you can see in that image does not have, the threaded location. All right, so that's in there. Now, line bias. So blue spring, valve, plug, dish side facing out, and then our cylindrical retainer. Alright, this is about as exciting as watching paint dry or grass grow. Sorry I can't be more entertaining. I mean, obviously feel free to skip this stuff, or this part anyway, if you're bored. But if you do plan on, you know, tackling this job yourself, this is to some extent a good representation of, you know, how it'll go for you. It'll probably go a little smoother for you because you're not trying to film it. Unless you are, then you'll have the same problems I do. Meaning that everything that can go wrong will go wrong. Am I too far in? I'm not far in enough. I think I'm too far in. Alright, I just want to check the bore plug to make sure it's not hung up in there. Alright. Our TV limit. No mods to the TV limit, at least not in this go round. That's actually associated with there. Duh. Duh. Like I said, you know, you're filming, things will go wrong. You'll have things in the wrong location, wrong position, and parts will fight you, you know, at every opportunity. They think they can get one over on you and make you look stupid. Guarantee it will happen. As much as you'd like to prevent it. Okay, so 3-4 relay, 4-3 sequence. Alright, again, this side with the double spools goes inboard. Alright, now we'll go ahead and install our TV valve. I have to go and grab another roll pin. I don't want to reuse this one. Alright, just as I was showing you the old TV valve roll pin, the battery went dead. So here's the old one, and here's a replacement. So like I said, anything that can go wrong will go wrong when you're filming. It's just the way it is. Unfortunately, this should work. All right, I'm gonna put a little bit of assembly lube here. You know, enough to get this valve and spring to kind of stick together. The spring will otherwise want to travel. You know, fall out or do whatever. So just like this, and it's going to go inboard like this. When I get it in the bore, and compress it all the way, like as far as you can get it. Now, as far as a roll pin, just get it below flush. And then check your valve, make sure it's moving. Make sure it's not sticking either. And the whole point of this is to make sure that the TV valve ain't sticking. Alright, now all the other rest of the ingredients. So, main TV spring, we're putting the original spring back in there. If he needs more TV pressure, then certainly he can swap to the other spring, and you don't need to drop the valve body to do that. Because this spring is slightly longer than the Transgo spring. I mean, we're talking maybe a 1/16 of an inch, but it's still a 1/16 of an inch longer. And they have you put a washer. So we'll put the washer in here, and then we'll go ahead and install this. Let's get that inner diameter of the bore there all soaked with WD. I mean, it's designed to be a tight fit. So just take your time with it. And if you need to, you can persuade it in. Just be real careful. I could tell the sleeve is ever so slightly off kilter. I think, but I might be able to straighten it out once it's in. Let's see. I want to rotate this counterclockwise to make this perfectly straight up and down. Because it went in just a little bit sideways, or not at an angle that's perfect. Alright, I think that's okay. All right, manual valve and little pressure switch, and this valve body is done. Done. think it finally stopped raining. That's good news. I don't know what the torque spec on this is. I'm sure there is one, but I just get it good and tight. Ain't gonna go nowhere. The German method, tried and true. And as I clean up my mess that I just made, fresh mess, I'm gonna pull this crap back in another plastic bag because it's not anything he's gonna need, and it's, you know, stuff that maybe I could use in a future build or, you know, whatever the case. All right, manual valve. Just goes in just like this, and that's the valve body. All right, auxiliary valve body, there is no alterations that you need to make to it. You just simply install it as you would from the factory. Okay, reuse the factory spring. No need to shim it, no need to do anything fancy. I mean, forward engagement is what it is. So if you watched the teardown video, you saw that I completely stripped or rounded off one of these bolts, so I had to replace it. And then in 91 and up, they started to install captured check ball here. This is where the check ball goes. So that you didn't have to worry about misplacing it or forgetting to install it before you bolted the auxiliary valve body back onto transmission. Alright, check balls are on the other bench, so I will put one on here or in there just before I put this back onto the case. Alright, I had to cut that bolt out basically, so cut the head off, and then once the head was off, I had the cover off, and then the rest of it just simply, you know, unthreaded by hand. Did nick up the cover a little bit, but it's not the end of the world. Not the end of the world. Don't have all my implements ready. All right, on these bolts I like 75-inch pounds. Too tight, you run the risk of rounding them off. And that's already at 75 at least. That was very close. All right, auxiliary valve body's done. All right, 1-2 accumulator. I actually have to go and pull a spring out of the drawer. I'm gonna use a sonic spring This Transgo doesn't give you springs in this kit. Alright, so Sonics makes two different types of accumulator springs for the 1, 2, and the 3, 4 positions. They have this one, which is 74926. This is a standard spring. And then they have another one, which I have the bag somewhere. It's not here. It's elsewhere, you know, on the property. But I'll flash the part number across the screen because I don't know what the hell it is. But the springs that come in this other kit, which again, same locations, they are much, much stiffer than these springs. I've used them a few times for the 4th accumulator, and you know, they had good effect. But for here, if you need to really crispen up your 1-2 shift for a very high stall converter, that's where you would, or when you would use one of those super stiff springs and then just drill the plate accordingly in combination with whatever else you've done when it comes to the 1-2, you know, the 1-2 hydraulic circuit and how you've calibrated it. But this spring should be fine. Alright, for 700 R4s and 4L60s up to 1994-95, for this first design accumulator housing with the large diameter pin, you install your piston in like so. Now Transgo has springs that, you know, they provide in some of their other kits. So you would have a spring seat that would go in here, I want to say a blue spring, the piston, and then on top of the piston you put an orange spring. In the HD2 4L60 E-shift kits, they give you what appear to be fender washers to shim this further. So there's a lot of different things you can do to the 1-2 accumulator circuit to calibrate it and adjust the shift speed and consequently firmness based on what you're trying to accomplish overall, you know, with your transmission. Alright, so 1-2 accumulator's done. Alright, let's bring the servo over. A whole bunch of servo parts. Alright, I want to make sure they're in view. So, this is the Sonics Super Hold Servo Assembly. It'd help if we had our sealing rings. Alright, you're going to use some of these parts in combination with some of the parts that came on the original assembly, and then you're going to discard the rest. You're not going to, if you're running the 2nd and 4th servos, you are not going to use any of the aluminum components. Alright, you don't have to take this out if you don't want. I mean, you can, you just blow air in there and this will pop out, but I'm just going to leave it in. What you do want to do is take this O-ring off. Alright, so we have two pins here. The pin that's wrapped is the Sonics pin. This pin is purposely too long. Okay, if you try and install the whole assembly as is, you're never going to get your cover past the snap ring groove, and that's designed that way on purpose so that you can dial in your band clearance perfectly by grinding on the tip of their their apply pin. So this is the pin that came out of the unit. What I'm going to do is I'm going to assemble this whole servo and make sure this fits. If not, then I'm going to have to find a different pin, which it's kind of looking that way. Yeah, I'm gonna have to go get a different pin. But the idea behind reusing the factory pin, at least so you can see what band clearance looks like, is to give you a quick and easy template to replicate. Because otherwise, you know, you're going to be grinding on this incrementally and it's going to take forever. And if you just go too far with it, then you're going to have to start over. I don't know if Sonic sells these pins separately or not, but like all companies, they overwrap stuff. It's like they make it a job for you just to get the whatever the product is out of the wrapper. And I'm not talking about just Sonics. I'm talking about pretty much everybody that's producing and selling any material goods. I mean, it doesn't matter what the hell it is. It's like they're way overzealous on the packaging. All right, that's how it should fit. All right, so let's see if we can measure the overall length of these two pins and compare them. Zero this thing and then see how long they are. Alright. First I'll measure the factory pin. I don't know if you can see that or not. Looks like 5.080. So 5.080 versus, looks like 5.155. So 5.080, 5.155. Alright, so it's 75 thousandths difference, which is actually not as much as I figured it would be. And the 3-groove pin that you see here is the shortest pin available. I believe it's the shortest pin available from the factory. The longest pin available has no grooves on the end of the pin. And then there's one that has 1 groove, there's a 2-groove pin, which is most common, and then the 3-groove pin. And that's your pins that are available. Alright, you can still buy these pins new. They're available in places like Amazon and other places. Trends, Parts Warehouse, whatever it takes, Performance, etc. So let me go find another pin and see if I can get it to slide in there, and then we'll proceed. Alright, I believe I found a pin that will work. Alright, so here are the instructions. This is going to be for the 4th gear servo. And they walk you through on how to set pin travel and all that good stuff. And here they're showing you how to use this as a gauge. And basically what they're saying is about 100 thousandths of an inch or so has to be removed from the pin. And that 3/8 washer is your guide, so to speak, or your gauge for assessing your progress. And then here is a little bit of information about the circuitry, here in the worm tracks, etc. That's where you're going to do your air checks. All right. So you can install the O-rings for your 2nd gear housing if you want. No harm in doing that, but I would leave the rest of them off for now. So I like this design. It's a you know, a kind of a double O-ring setup. So perfect for ensuring maximum sealing integrity, which is what you want in your servo. I mean, the factory servo, you have the one scarf cut seal, but in high performance, I mean, you literally need every drop of apply fluid, and you need these circuits to be 100%, you know, tight, so to speak. So this definitely helps out with that. A little assembly lube. And that would go on like this, but I'm not gonna put that on now. I'll put this in, put this on. I'm surprised they don't give you a little spring in here. So here's an example of a GM manufactured inner spring for this location. This is basically your 2-3 accumulator, and this would go in here. However, Sonics does not actually call for in their instructions for you to use anything in there. So let's see, discard OE servo assembly, second gear servo pin and spring, discard the OE pin, second piston and separator piston. OE cushion spring retainer and OE snap ring, and then the release springs. So they don't call for the use of an inner spring. This part of the piston here may be different, and as I'm talking this out loud, talking through it out loud, you know, it's occurring to me that that may be why. So I'm not going to install this, I'm just going to follow the instructions. If this was a factory Corvette servo, we would want to install something in that location. Alright, so this is going to be like our gauge. So, in fact, I got to measure this because it's different. It's a different pin. You don't want to just assume that it's, you know, exactly the same length as the other one if they have the same amount of grooves, because there's a lot of variability, and plus these pins wear over time. So looks like we are at 5.086. So 6 thousandths longer than the other one. All right. Now, of course, I don't have my E-clip. Alright, let me go find the little snap ring or a snap ring real quick. And then we'll put that together. And then we'll go ahead and I'll go to the press and install that bigger one on the other side of it. Doing great. Batting 1,000. Of course, I'm going to stab myself too with the screwdriver. All right, I'll be right back. Alright, servo assembly is put together, so we can now go ahead and assemble everything. And then for here, you're going to put the cut side of this washer facing the snap ring. And then go ahead and put your 4th gear servo on. Leave all your perimeter seals off for now. Alright, they can go on later. Alright, so for the time being the servo is done. We will need to assess our band clearance once the whole case is put together. In other words, we get everything from the back of the case to the pump installed for the final time, and then at that point we start trial fitting the servo and making our adjustments to dial into our band clearance. We want to see between 1/8 and 3/16 of an inch on the longitudinal travel of the band on the reverse input drum. Let's put these seals back in the little baggie. Alright, let's do our pump now. So quite a lot of parts are not going to be going back into this thing. Quite a lot. So this is everything that came out of it. We are not installing the original PR valve, the lockup valve, the PR spring, the boost valve. The only thing we're going to reinstall is the reverse boost valve and sleeve and the 2 springs for the lockup valve and the spring stop for the lockup valve. And I guess the snap ring too. So basically everything in my hand, is not going back in. This is all that's going to be going back in, that of all the parts that originally came out of this thing. All right. So this is the Transgo snap ring for the PR valve. That's your filter screen. This is the pressure regulator valve. This bag's open because I had to take this out so I can test it on the vacuum tester once we read the bore. You know, as I mentioned earlier, check out that video if you want to see how that's done. Okay, Sonic's boost valve with O-ring, 1/2 inch, just like the other one, but this has O-rings on it. If given the choice, always run an O-ring boost valve. I mean, they're kind of a pain to install, but you know, the benefits far outweigh the little bit of extra effort you have to make to get it, to go in where it needs to go. Okay, here's our lockup valve. This is for non-pulse width modulated applications. And then you have a little Teflon sealing ring here. So this you have to kind of stretch over and install. Just like that. I mean, it's not that big of a deal. Once it's in, you want to kind of massage it. And this one twisted up a little bit on me. Like I said, Murphy's Law with this stuff. Now, you don't want to get too aggressive with it. It's designed to be resized by hand. Okay, this will be coated with blue assembly lube before we install it. All right.
I was looking for the snap ring and I got tangled up. Okay, so the sealing ring is going to face out. Alright, once you get to the point where the sealing ring kind of comes in contact with the inner diameter, just kind of gently tap on it. It doesn't want to go right away. It's just best to yank it back out. Last thing you want to have happen is for the sealing ring to break. Recoat it, resize it. May help to put a little bit of assembly lube there in the mouth of the bore where the sealing ring would go. We got to do that with the boost valve as well. Alright, that felt good going in. Alright, got our snap ring groove exposed. So now we'll go ahead and install the little snap ring. I'm trying to get this to where you could see what I'm doing. But it's, I have to put it at an angle that I'm not, frankly, not used to, and that kind of stuff happens. All right, it's in there, but a little bit too much fanfare. All right, so I'm going to take this to the vacuum test machine and retest it along with the boost valve so we can record those values. All right, with the boost valve itself, you want to get a whole bunch of assembly lube in the bore here. And I'm just going to use my finger to lather up and coat the sidewalls and the inner diameter here with assembly lube. Now, it's absolutely vital that you don't skimp on the lube. Alright, this pressure regulator valve tested out at 20 inches when we were all said and done with it. 20 inches of vacuum, that is perfect. It's exactly what you want. There's flats already ground into it, that is sufficient. You do not have to grind it any longer, or any more I should say. Alright, falls right in. So it's this area right here. That's your balance spool, and that is what will wear. So here's your pressure regulator spring. Get that in there. And gotta get this boost valve out of here. So 1/2 inch diameter boost valve. I'll lather up the sleeve before I put the O-rings on to, you know, kind of mitigate the risk that, you know, you just have like a, I don't know, you go in at the wrong angle per se and you cut one of the O-rings. I mean, I have spares, but, you know, obviously you don't want to use it unless it's absolutely necessary. Alright, we gotta get that reverse boost valve and put that in. So for your reverse boost valve, this little orifice, this hole faces outboard and the valve goes in just like this. Alright, and then what I'm going to try to do is kind of stick a pick through the spring. To just, you know, hold a lot of the tension back so that I can put the boost valve in without the spring fighting me. We have our snap ring ready to go. There's a rounded side and a flat side or a cut side. The cut side faces inboard toward the valve. And like that. Sorry, I kind of have to hold it like this just to get leverage. Doing the best I can to keep it in the shot so you can see exactly what I'm doing. Come on. It's not in all the way. Okay, there it goes. All right, absolutely double check. You should see a little bit or feel a little bit of movement inboard with the boost valve. Okay, it is moving. And then for your PR valve, just double check. Lockup valve. All right. So the stator support is assembled. So that leaves the high rate return springs and the spacer plate. I'm going to do the spacer plate last, and I'm not entirely sure how I want to calibrate it. So that's why I'm going to hold off on it. I mean, it'll be in this video, but it won't be happening immediately after this particular segment. Get all this stuff that we're not really using off the bench or out of the way. And then this is the bag that's going to go to the customer. I gotta either give him these instructions with additional instructions, you know, that kind of expand upon what Transgo is telling you to do, because he's not a transmission guy, so I want to make sure that he has no problem following them, and then that way he'll have the information he needs to make fine-tuning type adjustments once he test drives this thing, and he can dial it in perfect. I mean, he's a handy guy, don't get me wrong, but a lot of my customers excuse me, a lot of my customers can rebuild an entire car from literally nothing. I mean, just all the parts, and they can put it all back together. The only thing they don't really want to touch is the transmission, and that's where I come in. So all right, we have the stator over here at the combined hydraulic test and repair station, and what we're going to do is vacuum test the boost circuit as well as the torque converter clutch apply valve circuit to confirm or deny that the valves we installed in place of the valves that were in there made any improvements. So we already tested the PR valve post repair. Like I said, you can watch that video if you want all the details, but we had 20 inches of vacuum once we were done reaming it, and that's perfect. So the boost sleeve failed miserably. It was only holding 6 inches of vacuum, but the TCC apply valve, both inboard and outboard, actually passed. So in normal circumstances, it would be fine to run these, but anything for high performance, I'm a big fan of installing the Sonix valves. They have 2 different ones. The valve we installed here is for the non-PWM applications, and then they have one that's intended for PWM 4L60Es, 95 and up, and that valve is anodized aluminum, where this one was steel. Both feature Teflon sealing rings to seal that circuit up completely. So I always have the test lead here in the calibration port, and so we're going to calibrate this real quick, and then what you do is you want to see 5 inches of lift when you turn the machine on with your test lead in the calibration receptacle, and then when you come over here on the side, you have your calibration port. You plug this with a finger, and you will watch the gauge jump from 5 inches up to somewhere between 20 and 30. You want to adjust your bleeder valve to get it to where it's reading right at 25, and then use your pump valve to dial in your base calibration 5 inches of lift. So we'll turn the machine on, we'll see where we're at. Looks like we're slightly above 5, so you're going to turn this clockwise to dial it into 5, and then we'll plug the calibration port. Looks like we're right at 25, and back to 5. So now we're ready to test. So let me zoom in a little bit because I would like to be able to have you see both the gauge as well as the circuitry clearly. Now there's a couple holes that we'll need to plug when we test this location here for the TCC apply valve and the boost circuit. So the boost circuit, you need to plug this hole here, and then for the TCC apply valve, you're going to need to plug this hole right here. All right, we'll go ahead and install the lead into our test block. And then let me zoom in so that we can get you positioned to see what's going on both on the casting as well as the gauge. That's going to be our first location we want to test. These hoses are a little ungainly. Alright, looks like we're at 19.5 inches on the inboard side of the TCC apply valve. So 19.5. Alright, now we're going to go outboard. You're going to put your test block right here over this little orifice. Going to draw a partial vacuum at around 9 to 10 inches. Now you're going to stick your finger in here to fully block the circuit off
push in a little bit on the valve until you get your max stabilized reading. So this looks like it's giving us 23. So that's what we'll record, 23. Alright, lastly our boost circuit. So remember, that's the fish-shaped depression here. And you want to make sure you cover the entire thing. This little corner right there likes to poke out. And then find your hole on the other side, the little port you got to plug, and it looks like we're at 24 inches. Okay, so I'm happy with the results we have here. So we can get them into the view. So 19 and a half, 23, 20, and 24. That is a very, very healthy combined circuitry for this pump stator. Very healthy readings, I should say. Getting my syntax, my word usage all messed up as usual. So anyway, this pump assembly here, the stator support assembly, is 100% good to go. So now all I'm going to do is install the bushings, put the pump together. That'll be in a separate video, and then this thing will be ready to drop into the case for the final time when we get to that point. All right. So, high rate return springs. I'm going to move this thing onto the vacuum test area. Alright, so you have two different styles of return spring assemblies for 700R4s, 4L60Es, and you have also two different styles for your forward and coast clutch return spring assemblies. So this is the second design, the dual retainer style that you would use with 97 and up bonded pistons. So molded steel rubber pistons or bonded pistons, you know, however you wish to refer to them as. I would install those pistons in this return spring in all 700R4s and all 4L60Es up through 1996. And 97 and up GM changed the design of the pistons, went from the aluminum ones that are prone to cracking, in particular the forward piston, and they went to the bonded steel and rubber pistons, which are basically as bulletproof, if you will, as you can get when it comes to transmission parts. So I would never recommend you reuse the aluminum pistons. The coast clutch and the 3/4 piston are not, you know, they're not problematic. The problem is the forward piston. It likes to crack pretty much anywhere along the body. I mean, I see them cracked along the legs. I see them cracked, you know, on the inner diameter. I've seen them literally cracked in half before. So that's what you want to avoid if at all possible, you know, when it comes to the forward drum in those older units. All right, so let's take a look at the high rate return springs. So these are designed for any application where you have a lot of engine power and a lot of RPM. So this is going to be the bleeder orifice that we need to install in the forward drum. We'll do that last. And then here are 3 sets of springs for your 3/4 return assembly. You're only going to use one of them. And then these are your return springs for the forward and coast clutch assembly. So this is a steel washer. It's designed to be used as an aid to compress the springs once you've installed the high rate versions when you go to install the drum snap ring, because
Unlike the factory springs, these Transgo springs are very, very stiff, and you run the risk of damaging your retainer if you don't have this steel spacer. So, like, don't get rid of this once you're done. You build any more, then I use this every single time I compress this assembly, whether I'm using or installing the high rate return springs or not. Let me get a bigger screwdriver. Let's try to clean up this bench. All right. So all you're going to do is just separate your return springs and then yank them off their spring seats one by one and replace them with the high rate counterparts. Sometimes you get lucky, you can literally pull them apart by you know, your bare hands against your body. Sometimes you can't. So you just want to get a few started and the rest will come out. So just like that. Doesn't matter if you break them, you're not going to reuse them. I gotta keep an eye on battery life. So if you have another technique that you use, by all means use it. You know, whatever works for you. The main thing is you don't want to damage the retainer. And that's you know, that's the main goal here when it comes to removing these springs, other than getting them off in the first place. And you also don't want to inadvertently stab yourself with the screwdriver. Alright, so you get enough of them off and they'll just, you know, the rest of them will just come right off. Alright, you can try taking them off with your finger, or hands rather. I mean, as you can see, they're not fussy. It's not gonna, oops, sorry about that. It's not going to cause you great pains. At least it shouldn't. Transgo instructs you to alternate these springs with the factory ones if you're doing anything, you know, under 5,000 RPM or moderate performance. You could do that if you want. I mean, I don't know that it's necessary. It only takes about an additional 10 psi marginal line pressure to fully compress this spring. So, all right, gotta change the battery out. All right, so the story with these things are, one side's ever so slightly wider than the other, so the narrower side goes onto the spring seat, and you want to either, you know, hear it snap in or click in, and then of course the other side goes on the other side of the retainer. And some will fight you. It's just the nature of the beast, I guess. I don't know if Transgo gives you any specific guidance about installation, but So for the 3/4, this is what we call the no hook style. So it's the first design. And they tell you to use either the white springs or the small plain springs. So the yellow springs will be put to the side. And yeah, no guidance on any special techniques or tricks, tips, or whatever to install these springs. You just install them like you see me doing. All right, I'll bring you back once they're all in and I have this thing assembled, and then we'll move on to the 3/4 assembly. Okay, the forward return spring assembly is all done. So, generally speaking, to install these, you want to kind of get one of the coils, length of the coil on the underside lip on one side, preferably the inboard side. And then once you have it kind of positioned, if you will, so you have, part of the coil underneath the little lip of the retainer or the spring seat, come with your screwdriver at the very base of the coil on the opposite side and then press down, and oftentimes that'll seat it for you. All right, we'll put that over there. And then the 3/4 assembly is a little more straightforward in that it's not as cumbersome as the forward. Now, with that said, neither one of these assemblies are as much of a pain in the ass to get the high rate return springs on as the 4L80E direct clutch. So 4L80E, TH400, TH400, you have loose springs. But for the 4L80E, if you have the high rate return springs designed to go in the dual retainer designs, then they are a bitch. My advice would be to skip all that, run an aluminum piston TH400, and just use the loose springs. They go in the spring seats cast into the piston itself, and you don't have to mess around with this pain in the ass springs for the dual retainer setup. Because believe me when I tell you, they are a pain. All right. So recall our instructions. So no hooks. We're going to try the white springs first. If they don't work, then we'll use the plain springs. And it's the same deal. You have a slightly smaller side and a slightly larger side. And like I said, if they don't fit, then you're going to have to use the other springs. So this side goes right over the retainers on that plate. I don't know if these are going to fit or not. Let me try these. Alright, I think we're going to roll with these. All right, let me get the rest of them in there and then we'll continue. All right, once it looks even, and you don't see any of the coils bound up, then you should be good to go. All right, So one thing I would advise you to do if you don't know the condition of the drum you're using because it's a replacement and you haven't had an opportunity to load it yet, I would leave these two assemblies out of it. Okay, I would install just regular factory ones in there so that you can do your pressure test, because it's a pain to deal with these. You really only want to install these assemblies once and that's it. So when I do the forward drum buildup, I'm actually going to use factory retainers because I know I have to take it all back apart again anyway. I'm going to build it up so that I can mock up my 3/4 clutch, dial in my clearance, and then once I'm good to go with everything, I know the drum's in good shape, I know that my clearance is where I want it to be, then I'm going to assemble for the final time. So that's these spring assemblies will go in, and the Sonic's drum reinforcement kit will be installed at that time as well. And that's why it has to come back apart again, because the last thing you want to do is install that sleeve that comes in that kit and then find out your drum's no good. So we're going to save this for after we validate the condition of the drum. So if you're in my position and you have a new drum that's not tested yet, don't install any of this stuff. If you're running that Sonic's reinforcement kit, don't install that either. Just assemble it as if it was a factory, you know, a factory drum, and with all factory parts. Test it, validate it, dial in your 3/4 clutch, get your clearance where it needs to be, and then assemble for the final time with your reinforcement kit. You know, that's the sleeve and the piston, and your return spring assemblies. All right, the last individual part we're going to work on is the spacer plate. So here's the original plate that came out of the unit, and this is how they you know, set up the orifice sizing for shift calibration. So they were a little aggressive on the 1-2 shift, at least in my mind, 125 thousandths. Third exhaust was also 125, that's fine. The band release is 93 thousandths, as well as the third gear shift, or, you know, shift for the 3/4 clutch at 93 thousandths. Manual low was 80 thousandths, coast clutch was 76 thousandths, and 3/4 was calibrated appropriately, I feel, at 125 thousandths with the fourth accumulator blocked. So again, this was in a transmission that was built and advertised to handle 500 plus horsepower. So I think they went a little light on the 3/4. So in other words, the 2-3 shift, but and they're probably a little heavy on the 1-2 shift. With all that said, I'm not going to drill this plate just yet because I want to actually have another conversation with the customer to get his perspective and learn how he felt about the shifting when the transmission was actually working and functioning as it should, because that'll inform what I need to do, you know, from a whole size perspective in this plate, and that's why I elected to purchase a whole new plate. So this is the Transgo 700P plate. This can be used on any year 700 R4, and it comes with two little slugs that you'll need to pound in to block off certain orifices in this plate based on whatever valve body and whatever vintage of 700 you're working on. Additionally, the 2&3 kit has its own series of plugs that we need to install as well. All I'm going to do, at least at the moment, is install the plugs where they need to go. Like I said, I'm not really going to drill the plate until I get my customer's point of view on how this thing was behaving and shifting relative to what he would prefer when it was working. You know, it did work for about 10,000 miles before it shit the bed, so. Alright, the kit does come with a cup plug, and this is intended to go in that, you know, fourth accumulator board to block that accumulator. If you've ever used pro-built automatics shift kits, they come with a plug, but it's orifice for that same location to restrict accumulator flow. So either way, all different methods to improve the 3/4 upshift and make it faster and, you know, consequently a little bit more positive relative to how it is from the factory. Alright, so there's a whole host of washers in here for adjusting your band clearance. And that's what these are. And they're intended for use with the assumption that you just have one apply pin, and that's the one that came in the transmission. Because we're installing a Sonics kit, we have two, and we're going to grind the Sonics pin to length once we know exactly what that band clearance needs to be, or I should say once we know what the pin length needs to be for ideal band clearance. Alright, so here are all the little plugs that come in this kit. Alright, so we orient the plate like this. In fact, let me label the circuits on here, and then we can kind of follow what Transgo's having us do. Alright, so this is going to be the plate, or the side of the plate that faces up when we put it on the belly of the case. So this is going to be 4th, 3rd, 2nd, 3rd exhaust, band release, and then over here you have coast clutch, and then this is going to be manual low. Alright, I had some other writing on the upper portion of that plate. It literally just says Transgo 2 and 3 and 3/4 shift valve. I mean, it was just more or less notes to myself for another video, one of the prior videos. Alright, so now we'll go ahead and flip the plate over, and we're going to follow the diagram and point out where we need to install plugs. So we'll label those locations. So here are our plugs. So depending on what valve body you have is going to determine exactly what holes you install these plugs into. So here's your type 1 valve body rubric or schema, and then here's your type 2 valve body. We are working with a type 2 valve body, so we are going to follow this schema here. Alright, so we're looking for plate on hole number 4, that's going to be here. So they're saying plug that. And then if you have 5 D and F, you want to plug those holes as well. So F is going to be here. Number 5 is going to be here, square hole. And then hole D. Where's hole D? There it is. So 5 D and F, that's what we're going to plug. Alright, the second thing that the instructions have you do is make a chamfer using like a 3/8 drill bit by hand. So on all the holes that are going to be plugged, they have you chamfer the plate. And they have you do it on both sides. So both sides of the plate. I mean, it doesn't take much, as you can see. Kind of difficult and awkward to do it on the square hole, but that's what they have you do, and they have you do it on both sides. And then from there, they have you just take a hammer and pound the slug in until it expands inside the respective hole. And then from there you file, you know, smooth it out with either a very fine file or, you know, a grinder with maybe like a wafer pad or something. All right, they recommend you use an 8-ounce hammer or so. So these are the instructions here. I think they actually want you to drive these things in with the hammer, but from the other side. Or maybe it doesn't matter, I don't know, to be honest. All right, I'm not gonna pick the valve body up, but my guess is that if you're gonna have protrusion like this, which I'm gonna have to knock this down, you'll wanna have it on this side, I guess, where, you know, this will just go into like a channel where nothing will happen, versus this side, which is gonna lay flat on the case. So you don't want the risk of cross leaks happening if you have protrusion like this. Okay, so we modified the plate per the instructions. Like I said, I'm not going to drill it at this point. I want to talk to the customer first, get some feedback from him, and then we'll go from there, and I'll make decisions at that point on orifice sizing. So from your point of view, it'll be more or less instantaneous, but from my point of view, it's probably not going to be for at least a day or so. All right, now we're going to go ahead and drill the plate. I did have a conversation with the customer. He talked me through what the shifts were from the previous iteration of this transmission, you know, with the, you know, the reman company did. And some of what he told me was actually kind of surprising, in that they had drilled the plate for your third feed and your band release to 93 thousandths, and he said that actually shifted super firm. So I'm not really sure why that is. The 700 R4s, to get them to shift firm, at least with even a mild stall converter, you got to open up the feed for the 2.3 to about 125 thousandths to start. So we're going to follow the instructions here contained within the shift kit. We'll let him test drive it, and then if we need to, you know, we'll make adjustments, swap in a different plate with a either, you know, if we have to go more conservative, you know, if it's bang shifting, or if we have to open it up, we'll just simply open up holes. But this kit should give him what he needs, and based on Transgo's rubric, and give him the shift firmness that he's looking for. So here's what we have. So we're going to start out with a second feed at 93 thousandths. All right, if you were running the Corvette Servo, assuming everything else equal, you would probably want to start this at around 100 to 110 thousandths for a mid to high stall application. He's at 2500, 2800, maybe up to 3200 stalls, somewhere in that regime. But because we're installing a super hold servo for second gear, that's going to give a firmer shift by itself. So we're going to go a little bit conservative here. We don't want him to have overly harsh part throttle 1-2 shifts. Okay, so for your 2-3 upshift and your third exhaust, we're going to drill these to 157 thousandths, our band release to 110 thousandths, and then our fourth gear feed to 157 thousandths. He did remark that this was overly soft. It felt soft shifting. So we want to make sure that the shifts are crisp at part throttle and crisp to slightly firm at full wide open throttle. We don't want any bang shifting. Bang shifting will result in parts breakage. So that's what we're going to do. And here's a close-up of the instructions to kind of show you what the rubrics are. I mean, it's slightly different for Type 1 versus Type 2 in terms of feed hole sizes, but for the most part, it's setting you up for the same kind of shift feel, you know, for the drive cycle. He also said that it would shift firmer cold relative to when the transmission got warm, in other words, at operating temperature. And a lot of these things are likely due to impairments within the hydraulic circuitry. He had an excessively warm pressure regulator valve. I'm venturing to guess the original throttle valve and sleeve and plunger were also not sealing as well as they could have. And of course, the input drum was leaking at the base where the shaft is pressed into it. So I think those things kind of combined to, you know, produce the symptoms and the shift feel that he had experienced. So hopefully what we're doing here will restore order, so to speak, and give him a nice shifting transmission that he's going to be able to enjoy. All right, so what I'm going to do is I'm going to open up all of these holes other than this one to 110 thousandths, and then I will finish them off either with 125 thousandths as an intermediary size, and then finish them at 157 or go right to 157. But first we'll drill with 110 thou. And let me get my safety glasses on. I don't want any
shrapnel flying up and poking an eye out. So eye and ear probe. So we'll do third feed. So this is 110 for the band release. This is going to stay 110. And then third exhaust. And fourth gear. All right, and then 93 thousandths on our 1-2 shift feed hole. All right. So whenever you have fairly large orifices you're drilling out, you're going to have, you know, burrs and sharp edges and whatnot. You want to take like an angle grinder and a wafer pad and deal with those. So let me go grab that. All right, this plate is ready to be bolted on to the case when we get to that point. All right, we have come to the end of everything we need to do to install this complete kit. So there are 2 filter screens we have to install, and they come in your main overhaul kit. And then there are 2 orifices that we have to install that come in the Transgo 2 and 3 kit. So here are the 4 items. These orifices are conical, okay, they're tapered. This is the end here, this end with the cup is going to face up or face you. this end is going to face into the case. Okay, this end here is roughly 297 thousandths of an inch wide, and this end is 305 thousandths of an inch wide. So I'm going to use a roll pin punch that, you know, fits just inside here, engages the you know, inner diameter of the cup there, and then I'm going to use a regular drift punch for these little filter screens. So here's the instructions. There's where they go. When I say they, I'm referring to the little cup plugs. The filter screens themselves aren't shown. So one's going to go into the low reverse feed passage, and the other is going to go into the governor feed. Looks like these things are stubborn, or I had this thing cockeyed. Get a bigger drift. And I'm not really liking this. Yeah, I think I'm gonna had to change the angle on it.
I may need to drill that out just a little bit. I may have peened it shut with the roll pin punch. All right, this one went in perfect. This one, I started it somewhat cockeyed and then I redirected it, but it wasn't as smooth, not by far. So, I mean, they're both in and they're both more or less flush with the casting, but like I said, this one was a little bit more difficult, and could have been me. I know I started it a little bit too steep, had to redirect it, but it's not nice and clean looking like this one. So I'm going to go ahead and install the filter screens. We'll do this one first and I'll zoom out so we can do the one toward the front of the case. You can see it. Instead of zooming out, I'll just change camera angle. Okay. So that's the last significant step we need to do. So let's change a camera angle and we'll talk about check ball placement, and I'll put the 2 check balls in the valve body where they need to go, and then that will literally be it. All right, check balls. So on the valve body for first design or early valve bodies, you're gonna have 3 check balls. A check ball here, here, and here. For a second design, where there is an auxiliary valve body, you're only gonna have 2 check balls here and here. For a 1993 model year unit, you're gonna also have a check ball, a 3rd check ball toward the other side of the case there. So you build 700R4s for all 60Es, T350s, etc., GM, Ford, and Dodge transmissions of this relative vintage, 60s through say mid 2000s. You want to get this check ball book that the ATSG manual produces. Okay, this is a great book because it'll give you all of the check ball locations and their designations, and to some extent their function for a multitude of different transmission families and types. So GM, Ford, and Dodge, from basically TH400, C6, all the way up through 4L60, 4L80E, and equivalent vintage Ford and Dodge units. Okay, so again, very, very handy to have so that you can begin to understand exactly what's going on when it comes to hydraulics and check balls, hydraulic circuitry routing, along with what the purpose of why this particular circuitry was designed the way it was designed. What it does in the broader context of the transmission's operation and function. So it's something I'd highly recommend that you grab. There's, I think, 4 volumes, 4 different check ball books, foreign and domestic, and then you have transmissions of this vintage in 1 volume, newer, later model domestics in another volume, foreign, and so forth, and then earlier foreign stuff in yet a 4th volume. I think there's 4, don't quote me on it, but this is the only one I have. It covers pretty much everything I really need to cover, though I'll probably pick up the other 3 at some point soon, just to have them. All right, so with that said, you can tell based on this diagram here in front of you what these check balls are. So this is going to be your drive 3 check ball, so number 6 check ball, and then this one here is going to be the 3rd accumulator clutch check ball. So again, having this information is very helpful. All right, so we'll look at the case real quick. You see that for 88 through 93, you have a different configuration than you do for your 87 and back. It's technically 1987, or 87 is kind of a funny year, so you really need to pay attention as to what you're working with. But if you get a 1987 unit in, so this check ball is the large TV exhaust check ball. If your throttle valve pressure is not set correctly, or I should say is not sufficient because the TV cable is not set up or adjusted correctly, this ball will seat and max the line pressure. It's kind of like a safety mechanism. Okay, Transgo in their kit here is having you reinstall this check ball here for your accumulator because, again, it's more of a safety backup. Even though you've plugged that large check ball seating location in the plate, if that little slug falls out, you have a check ball to back you up, and so that the transmission doesn't experience a problem. All right, for our case, just getting back to this, you will not install the number 1 check ball if you're deleting the 4th accumulator. It could be left out. We are going to install the number 3 check ball. That is our par throttle drive 3. And then we're also going to install 4 and 8. So go back to Transgo's instructions. That's what they have you do. So this number 1 check ball is for your first design 700 R4s or first gens, no auxiliary valve body. Your number 2 check ball is installed on all years, but we are only going to install this one and these 2 in the case. I don't have a large TV exhaust check ball. A lot of builders leave them out. The previous company that built this thing is no different. All right, so that's the bit about check balls. Obviously, I'm not ready to put any check balls onto the case, so we'll get the valve body out of the way. And then we have our forward drum that we want to run. So what I need to do is fill this drum with, not those 2 return spring assemblies, just, factory unmodified ones. I'm going to just literally put a set of used pistons in here, build it up, and pressure test it so that we know it's good. If it's not good, then obviously we're not going to use it. And I don't want to modify it. I don't want to install any Sonex reinforcement kit or anything like that until I know this drum is validated to be good to go. So let me go ahead and do that. I'll build it up partially with that used stuff I just mentioned. We'll put a little fluid in here. We'll test this and see if it has any bubbles. And I'm going to put a clutch pack in here too for the forward and coast clutch and 3/4, so that it, when I put air into the circuit, it's not going to bust out, 1 or more pistons. So anyway, let me do that and then we'll come back. Okay, we have fluid just sitting here at the base where the shaft's pressed into the drum. So now what we're going to do is introduce air into each of the apply circuits, starting with the third clutch feed. That's where we see most of our issues. So this is going to be the third clutch feed. Here we have forward, and then we have coast clutch up here. When you introduce air into the coast clutch, you want to block off the forward feed passage, otherwise air will just come out the forward. And I mean, it's not going to really affect your test results, but it'll be distracting. All right, third clutch feed. Again, drum is completely stock. All the clutch packs are installed. Let's see what we got. All right, I'm putting about 75, 80 psi of air in here. Maybe more, maybe 100. To be honest, I didn't look at the regulator. Let me look. (100 psi) is going into this circuit. And I do not see any bubbles. So you want to do this multiple times, multiple times, just to be 100% certain that you don't have problems. All right, so that was the 2-3 feed, or feed into the 3-4 clutch pack. Now we're going to do the forward. All right, I'm charging the circuit here. All right, that was real positive. In other words, good. So what I'm doing is I'm putting air into the forward feed, releasing the trigger. You notice how air is staying trapped when I have the nozzle hard and fast to the orifice. And only when I release it is the air rushing out. That's what you want. And I don't hear any kind of hissing coming from deep within the drum. If you heard that, that would indicate that the forward piston housing is no good. And remember, these are used pistons. I haven't even installed the new pistons yet. All right, so let me plug my forward feed and we're going to do the coast clutch. That sounds like UPS. Okay, that is really good. All right, no holes in this drum, so this drum is good to go. We're now going to go ahead, knock out this little ball capsule here for the third clutch bleed, and we're going to install the Transgo capsule. And that is basically it as far as this shift kit is concerned. So as far as final installation, assembly, and all that, I'm going to film that too, just to kind of close the loop on this transmission. This way the customer has a 100% full video library of everything that I have done to it from start to finish, from the time it came in here through teardown, through kind of a retrospective deep dive perspective on that when the parts were clean and whatnot, up through to final assembly when it was all buttoned back up and everything in between. So let me go ahead and get this stuff out of here. One other thing I want to do is measure the 3/4 clutch pack clearance. So I'll show that too real quick. Totally forgot about it until just a second ago. So I want to do that, and then we'll go ahead and install that orifice. Because then from there, we're going to install the Sonics reinforcement kit for this drum, which comes with a steel sleeve and a specially designed piston that is intended to work with that kit. So the piston in question is the overrun piston. All right, let me get this fluid out of the way, and then I'm going to reposition the camera, get a dial indicator set up, and then we'll go ahead and check our 3/4 clutch pack clearance and forward clutch pack clearance. Because, I mean, other than like the difference in bonded pistons, I have the Hyper Blue piston set that I'm going to be putting in. Everything else that's in this drum right now, as far as clutches and steels and backing plates, is going to be in there when we're finished with it for the final time. Dial indicator set up. We have the drum fully mocked up, so now we're ready to go ahead and take a 3/4 clutch pack clearance. No load release springs. Do not put load release springs when you measure your clearance for these transmissions. Alright, 42 thousandths is good to go. I like to measure it here 180 out from the opening of the snap ring groove, and that's so that you're not kind of getting a false artificially inflated clutch clearance reading because the snap ring itself's flexing a little bit. All right, I've seen that before. You can go, say, 90 degrees if you want, and then I guess 270, and see if that like makes a difference at all. All right, so about 38 thousandths. So what did we say? 40 thousandths, 38 thousandths. Because of the way my bench is, I'm not going to be able to actually put this thing here and have access to the 2/3 feeds. So I'm going to say I'm somewhere in that 40 thou, 38 thou range. And for 3/4 clutch pack clearance, that's perfect. Now, Transgo will tell you not to reinstall the load release springs when you're using their high rate return springs. Now, my guidance on this is to reinstall them, even if you have the high rate return springs installed, if you suspect or know that the transmission will see more than 7,000 RPM. And I'm looking for the page where they actually tell you this. Oh, you know what? It's in their other set of instructions. There's another page, just a one-sheeter where they talk about that. All right, let me empty this drum back out. We'll stick this thing in there, and then we'll summarize. All right, our last act that we have to perform to complete the installation of this shift kit is to go ahead and knock the stock third clutch bleeder ball capsule out of the drum and install the Transgo capsule. So just take a drift, position it, and punch it out. Just wipe the inside of the drum. Turn it upside down, put it, into a bench with a hole in it. And then go ahead and install the Transgo capsule in its place. And of course, don't be a clumsy klutz like me and just throw it all around. That was the old capsule. Here we have the new capsule. Well, like, what the hell are you doing, dude? Smack it until it's below flush. And that's how you check it. All right, let me move the camera back. We'll kind of summarize all from my, parting thoughts, and that will be it. So there you have it, the Transgo 700 2 and 3 reprogramming kit. So it is quite an extensive kit, as you've seen. We've covered pretty much every aspect of the kit other than the full manual control. I mean, you see the instructions, you can look them up online. A link is in the description, but we did not perform those particular steps to convert this to full manual control. That's not what the customer wants. He wants to keep his forward automatic shift pattern. But every other aspect of the kit was covered here. So would I recommend this kit for you? I actually would. I think it's a great all-around kit, and I think it's also amplified by the 3/4 shift valve, or throttle valve for the 3/4 that Transgo offers as well. And between the two of them, make a very nice pairing for high performance or really heavy duty hydraulic recalibration, as well as reinforcement of some of the weaker areas in these transmissions. So what I have here on the bench are the apply and backing plate set for the 4L65Es. So if you wanted to purchase that clutch pack, you would need this set. So the pressure plate, which is the one with the legs, is 242-17451. And then the backing plate, which goes on the very top of the clutch pack, is 242-12459. Okay, don't try to use regular 4L60E apply and backing plate set. You'll never get the clutch in there. They're too thick. So 4L65E clutch stack is going to be 7 frictions, 6 steels. We're using Borg-Warner high energies. They're a great all-around clutch. If this was going to be more of a race-oriented vehicle where he's taken to the track all the time, I probably would have ran Alto Reds or Rebestis Blues. But the Borg-Warner high energies are really, really good, and ideal for kind of general purpose, fun vehicle performance, etc. All right, so we did all kind of mods to the valve body. I annotated the video with some commentary around why we were drilling the holes we were drilling, but let me kind of cover that verbally here so you have the context. So this hole right here, which is that 157 thousandths hole that's drilled through the bathtub, is actually to redirect oil into the manual low circuit so that it fills out, or flows into the entire underside of the low reverse piston. And so it's not like this from the factory. You're only using part of the piston in manual low. In reverse, it's fully applied but not in manual low. So you're in effect dual feeding the low reverse clutch in manual low, and that's good for performance and for heavy duty. The other holes are as follows. So we had a hole here, which is in this cavity, and then we had a hole here. This hole is designed to give you what we call gear command. So when you're in manual low, if you accelerate to a certain point, you reach a certain road speed, the transmission is going to forcibly upshift you from manual low to drive 2. And that is irrespective of what you do with the column shifter. What this does is it defeats that, it overrides it, so it gives you full control, or the parlance and term we use is gear command when you're in manual low. So it gives the driver some ability to control his shift points in a manual shift situation. And then lastly, this hole right here is designed to push the 3-2 control valve or 3-2 downshift valve inboard, so that basically when you downshift from 3rd to 2nd gear, this thing has oil pushing it inboard so that you make a crisper, cleaner shift. It more or less streamlines the 3-2 control circuit, and that's what Transgo is having you do. So I'm the type of person that if I'm going to make mods, I like to know and understand what it is I'm doing and why I'm doing it. And that helps me also explain it to customers in the event they have questions, or if anything comes up from a drivability symptom standpoint, I can at least draw on that knowledge to help me diagnose a problem if that problem is associated potentially with one of these mods, or in that clutch circuit, or whatever the case may be. So anyway, that's the video. Hope it was informative for you. Hope it was educational, maybe even mildly entertaining. You get this, see me fumble around here and there occasionally, and that's always fun. So
But like I said, I wanted to put it out there primarily so that my customer has a video record of everything that is done to the transmission, including all the hydraulic reprogramming that we're doing to support his application and meet his needs. And then of course, for my own sake, obviously, so that I can bring more content to you guys and, you know, get more content out on YouTube. So until the next video, thanks so much for watching. I am going to film the buildup of the transmission. So like I said, he'll, my customer meaning, have everything from start to finish on tape or on video so that he can refer to it, and, you know, so that I can refer to it, and more importantly, so that you guys can learn from it. All right, guys. Again, thank you so much for watching. Greatly appreciate it, and look forward to seeing you on the next video. Take care.